Okay, so today we're looking at force due to friction. So before we actually get into friction, there's a few concepts we have to make sure we remember. First one was net force. So we looked at this when we did free body diagrams a few days back. So what net force tells us, if you were to take an object and add up all the different forces acting on it, so if we actually look at this question down here, if we have 4 forces acting on an object that's shown, what we can see, well, net force is if we combine all of them, we're just thinking about what's left over. So when you look at this, it's 6 newtons up, 6 newtons down. If 6 newtons is up and 6 newtons down, we know that those are basically going to cancel each other out. But if we look at the right and left, the force to the right is much greater to the force to the left. So we know our unbalanced force is going to be 17 newtons to the right. So this is our net force. So basically what it comes down to is if you take all of the applied forces and subtract all of the opposed forces, that's going to get you your net force. Just like we saw in kinematics too, we can separate things to the x and y axes. So we have to look at things along like one vector direction, so like in the x direction or in the y direction. If our net force ever equals to 0, it means that there is no acceleration. Or no acceleration doesn't necessarily mean it's not moving. So no acceleration could mean it's stationary or it's moving at a constant velocity. If our net force does not equal 0, that means there's an unbalanced force and there's going to be acceleration. So it's going to be speeding up or slowing down in the direction of that unbalanced force. So let's finish this question. So it says, in which direction will the object accelerate? Well, it's in the direction of the unbalanced force, so to the right. And C, for there to be uniform motion, what additional force must be applied to the object? Basically, if we want uniform motion, there must be an additional 17 newtons to the left. That would balance out the force to the right. Our net force would be 0. We'd get uniform motion. For this question that we kind of skipped over, in a tug of war, the two teams are at a standstill. One team is pulling with a force of 215 newtons left. What must be the force of the other one? It's going to be 215 newtons to the right, for it to be balanced out.